Okay, we can use mass percent as a conversion factor. Mass percent can be a conversion factor between mass of the element and mass of the compound, because percent literally means per 100. So here's an example. Freon 112 is 69.58% chlorine by mass. So then we can make a conversion factor from 69.58 per 100. So 69.58 grams of chlorine, because it's this percentage chlorine, per 100 grams of compound. So what mass in grams of iron 3 oxide contains 58.7 grams of iron? Iron 3 oxide is 69.94% iron by mass. So we are given the percent by mass and a mass of iron. And we want to find the mass in grams of this compound. So if we're just thinking about this as dimensional analysis, which we certainly can, we're going to write down our numbers. So that many grams of iron, and 69.94%, I'm going to write that as 69.94 grams of iron per 100 grams of the iron 3 oxide. And we're short on time, so I'm not going to review how you find the formula for that. And then what I want to do is I want to find grams of Fe2O3. So the percentage here relates the amount of iron to the amount of iron oxide. This is a conversion factor. This cannot be used as a conversion factor, and so that's the number we're going to start with. And I left this big, huge space in the middle, but it's just really one step. So 58.7 grams, that doesn't look like a 7, of iron. I'm going to convert to grams of iron oxide, and I'm going to divide by grams of iron. So again, I'm getting my units to cancel out. This conversion factor comes from the percentage. I took the percent that I was given and I interpreted it as grams per 100 grams. So written here, I have 100 grams of Fe2O3. So up here where it says Fe2O3, I'm going to write 100 and 69.94 grams in the bottom. If you're interested, because this is a percentage, that 100 is exact. So 58.7 times 100 divided by 69.94, and starting with 3 sig figs, so my answer should have 3 sig figs. 83.9 grams of the compound. The mass of the compound needs to be larger than the mass of the thing that's in it, right? This is not the only way to solve this problem. If you're good with percentages, you're fine, but a lot of us aren't. And I mix myself up with percentages sometimes. And so it really helps me to write it like this, because then it just becomes a conversion factor. And it's not, am I supposed to multiply by the percent as a fraction or divide by it? I don't like questions like that. 83.9. No trains, so it's got to be a motorcycle. So we should know how to do problems like that with percent as a conversion factor, but that's not what we usually do in chemistry. Usually we get our conversion factors from chemical formulas. Because the formula gives us the relationship between numbers of atoms and molecules or moles of atoms and molecules. This formula C2Cl4F2, if we're looking at how much carbon per how much of the compound, well, there's 2 moles of carbon, right, in 1 mole of the compound. If we want to look at the chlorine, well, there's 4 moles of chlorine in 1 mole of compound. What would it be if we're looking at the fluorine? Two moles of fluorine per 1 mole of compound. But this sort of relationship is between numbers of particles, amounts in moles. It's not between masses. But chemists care about the number of moles more than they care about the mass, so it works for us. Determine the mass of oxygen in a 7.2 gram sample of Al2SO43. I've got one number there. And we want the mass of oxygen. So I have 7.2 grams of Al2SO43, and I want to find grams of oxygen. The chemical formula gives me the relationship between moles of oxygen and moles of the formula, moles of molecules. We could use the formula and calculate the mass percent and do it that way, but it's not going to be any faster. So we're going to go to moles in the middle. I can convert this mass of compound to moles of the compound using the molar mass. Oops. And did not leave enough space. Make more space. And then I can convert moles of the compound to moles of oxygen. And then I convert to grams of oxygen. And this is where, because we've got grams of 2 different things and moles of 2 different things, you really want to write grams of what? Because otherwise you're going to get it all mixed up. So this is grams of Al2SO43. I know it's tedious. I don't like doing it either, but I'm kind of stuck with it. We can convert that to moles of that same stupidly long formula, to moles of oxygen. Thank goodness, 1 letter. 2 grams of oxygen. There's 3 arrows. There's 3 conversion factors. Grams of this to moles of that to moles of the other thing to grams of the other thing. And then I bring these units down below. So grams of aluminum sulfate, cancel grams of aluminum sulfate. Didn't leave enough space. Oh well. I'll just kind of make it come down here. And this is going to be moles of oxygen. How many moles of oxygen are in 1 mole of that compound? Same motorcycle. How many oxygens are in... No fresh air for us. How many oxygens are in here? We're not talking about masses. In 1 formula unit, how many oxygen atoms? 3 times 12? 3 times 4 is 12. So there's 4 oxygens here, and this tells me there's 3 of those groups. So there's 12 oxygens. So there's 12 moles of oxygen in 1 mole of compound. That comes from the chemical formula. The other 2 conversion factors are molar masses. The one for oxygen is pretty simple. We just look at the periodic table. 1 mole of oxygen was 16 grams. And then this one for the compound we have to calculate. And there's 3 sulfurs. And there's 12 oxygens. If I screw something up, please tell me. Did something wrong. You couldn't see it. Syntax error. Okay. 342.17. Anybody agree? Anyone disagree? Yes. You disagree? Okay. So that's the mass of 1 mole of that thing, right? So 1 mole of aluminum sulfate weighs 342.17 grams. So 7.2 divided by 342.17 times 12 times 16. And this would have 2 sig figs, right? So 4.0 grams of oxygen. I'm just curious. Hey Siri, what is the mass of oxygen in 7.2 grams of aluminum sulfate?
I found this on the web.
Yeah, it's not going to, I mean, it's going to give you...
Here's how do you find the mass of oxygen?
It's not just going to come up...
Hey, babies, silky soft essentials
that
move...
It's going to lead you to some videos of somebody explaining how to do it, but it's not going to give you the answer, right? This is why we need to learn dimensional analysis.
Sorry.
That's okay. That's why they make them sturdy. Okay? Let's see. 4.0 grams. There's the train.